Hello, everyone. My name is Daniella Guzman, and I am a third-year veterinary student at The Ohio State University. Over the past year, I've had the privilege of conducting research at the wilds. During my research, I was able to write up a clinical brief on eastern hellbenders. The eastern hellbender is the largest aquatic salamander in the United States and can be found in streams from southern New York to northern Alabama. Although some populations remain healthy due to habitat loss and degradation, the hellbender is listed as near threatened by the IUCN and is close to qualifying for vulnerable status. In addition to their IUCN status, some natural populations, such as those in Missouri, are listed as federally endangered and are protected at the state level where they occur. Due to their status, various zoological organizations in multiple states have created Head Start breeding programs in order to improve hellbender populations. Today I'll be presenting the clinical brief on the treatment of Batrachochytrium Dendrobatidis in eastern hellbenders with terbinafine. Batrachochytrium Dendrobatidis, which will be further referred to as BD, is one of the highly infectious etiological agents responsible for chytridiomycosis. Chytrid is a potentially fatal disease that has been reported as threatening 48% of amphibian species with extinction and is believed to be responsible for widespread global declines in amphibian populations. While most amphibian species are likely able to become infected with BD, not all will develop chytrid or die when experimentally or naturally infected with BD. Through the use of quantitative polymerase chain reaction, or qPCR, previous reports have demonstrated that skin swabs collected from wild populations of eastern hellbenders throughout their natural range have tested positive for the presence of DD despite lacking clinical signs of illness related to chytrid. These studies suggest that eastern hellbenders may be capable asymptomatic carriers of chytrid. Recent evidence from hellbenders collected in New York also suggests that BD infection can impede success for hellbender release programs due to the risk of transfer of BD spores to more susceptible amphibian species within their habitat. Due to high mortality of chytrid in other species and potential impairment of BD to hellbender release programs, routine screening and treatment of hellbenders for BD is vital to prevent the spread of BD to susceptible species and potentially improve release outcomes following Head Start programs. 2014, 2 adult female hellbenders were acquired by the wilds as part of a Head Start breeding and education program. During initial acquisition of the hellbenders, blood was collected for a complete blood count and serum biochemistry. Skin swabs were collected for BD testing using standard protocol of gently passing a swab 5 times over the ventral skin surfaces, including the pelvic patch, ventral thighs, and toe webbing of each foot. After samples were collected, animals were individually housed for a 30-day quarantine period. Physical examination, complete blood count, and serum biochemistry were unremarkable. Skin swabs were negative for BD via qPCR. After completing quarantine, both hellbenders were housed in a 500-gallon stream tank with a mesh divider between the 2 individuals. Life support for these individuals consisted of a sand filtration system and testing for nitrates, nitrites, ammonia, and pH on a weekly basis. In 2019, Case 1 was examined and tested for a Batrachochytrium species as part of a pre-shipment examination prior to transfer to another zoological facility. Skin swabs were collected using standard protocol and tested for BD and Batrachochytrium salamandrivorans, or BSAL for short. Case 1's physical exam was unremarkable and the water quality was within normal limits. Chytrid testing was performed at the Wilds Conservation Science Training Center. Testing for BD was performed using qPCR in a multiplex, using previously published primers and probes, and using a synthetic G-block of the target DNA sequence to create a standard curve at 4 dilution levels for each run. Each sample was run in triplicate using qPCR reagents and thermocycling conditions. Due to sharing the same water system as Case 1, Case 2 was tested for Batrachochytrium species using the same methods previously described. The skin swabs for both Case 1 and Case 2 were qPCR positive for BD and negative for BSAL. Water in the shared tank system was tested for Batrachochytrium species via qPCR, and results were negative for BD and BSAL. A course of terbinafine hydrochloride and alcohol, or LamisilAT Spray, was chosen for treatment based on a previous report in amphibians and simplicity of treatment. The treatment regime consisted of adding 15 milliliters of LamisilAT to 3 liters of tank water, and each hellbender was soaked in the solution in a separate 10-gallon tank for 5 minutes once daily for 5 days. After the 5-minute medicated bath, Both Hellbenders were returned to the same original tank system throughout the duration of treatment. Both Case 1 and Case 2 remained active, exhibited normal behavior, and continued to have normal appetites throughout treatment. There were no obvious signs of ill effects observed during or after treatment. Skin swabs were collected individually from Case 1 and Case 2 at 1, 3, and 4 weeks post-treatment for qPCR testing for BD and BSAL. All swabs were qPCR negative for BD and BSAL. Both Hellbenders were deemed free of BD infection upon completion of treatment with no ill side effects. While terbinafine dissolved in alcohol at 0.005% and 0.01% has been successfully used to clear BD infection in several amphibian species, this is the first report of terbinafine dissolved in alcohol at 0.005% being used to successfully treat BD in eastern Hellbenders. This clinical brief documents a successful treatment protocol for eliminating BD infection in 2 adult eastern Hellbenders and underlies the importance of routine testing for BD in amphibians prior to transfer to different facilities or return to the wild. Routine testing of amphibians minimizes the risk of disease introduction via carrier species into a new collection and may improve release success for Hellbender Head Start programs. I would like to thank my co-authors, Drs. Priscilla, Joyner, and Stephen Spear, for all their support in this project. I would also like to give thanks to the Department of Animal Health and Wildlife Ecology at the Wilds, to Christina Black, who extracted swabs and ran qPCR, Brandon Brown, who assisted with swabbing, Janelle Urig for providing the photos in this presentation, and Dr. Joe Greathouse, who initially collected individuals and provided guidance to the Hellbender program. Thank you, everyone, for your time and attention, and I hope you enjoy the rest of the OWMA conference.